Welcome to the office. We want to take another look at evaluating an integral where the method is not given to us. So again, we'll walk through the same process of looking through the guidelines or the procedure that has been outlined for us in a previous video. So we ask ourselves first, can the integral be simplified? So here we have the integral of sine of x plus cosine of 2x being squared dx. When I look at this integral, I really want to perform a u substitution simply because I don't like this trigonometric thing being raised to the second power, right? It's the sum of trigonometric functions. So I don't really like this. So I say let's rewrite this a little bit differently. But let's walk through the procedures that have been outlined for us. So we ask ourselves, can this be simplified? I mean, there's manipulations that we could make, but can it be simplified? I'm not really sure. It'd be nice if sine of x and cosine of 2x, right, were both in terms of x, not x of 2x. So maybe that would be a simplification, but I don't know if that's what I would do right away. So can it be simplified? Meh. Is there an obvious u substitution? No. You might think to yourself, oh, well, when we have a trigonometric integral and it's an even or an odd power sine or an odd power cosine, we just convert the other to we make the pull out the factor, convert to the other, blah blah blah. Right? Procedures for evaluating trigonometric. We should be somewhat familiar with that. But we don't have exactly that here because it's addition separating these two trigonometric functions, not multiplication. So, so we don't have that it's a trigonometric function. Or we don't have that, that's the obvious u substitution. So simplify, obvious u substitution, generalize or categorize the integrand. It is trigonometric functions, so that's probably the way we're going to end up going. But it's not very nicely inside that box of how the procedures work for evaluating integrals in terms of sine and cosine, right? Where the integrand involves sine and cosine. It's not that nice product. So we maybe move on to double check the others. Let's see here. Is it a product of a polynomial and a transcendental? No, so probably not integration by parts. Is it a rational function, polynomial divided by polynomial? No, so it's probably not going to be partial fractions. And are there any square roots that look really nice to encourage a trigonometric substitution? No, I don't see those sorts of things either. So the only thing that looked halfway decent is the idea that yes, this is sine and cosine, so let's use those procedures. Maybe that's what you would have started off with right away because you simply recognize those. And that would be fantastic because if you can recognize it quickly, you don't want to spend the time going through the outlined procedure of how to decide which method. So let's see. How do I handle this? Well, I said once that I'd like it to be in terms of x, not 2x. So maybe you could perform that substitution, but overall, you're going to have to multiply this out, unfortunately. So I'd rather multiply out a binomial than square a trinomial, right? Square a binomial or trinomial. Squaring a binomial is much easier. So if you have to write out all the work, then definitely binomial is way better. So I would encourage you to maybe consider that. When I square sine x plus cosine of 2x, I obtain sine squared of x plus 2 sine x cosine 2x plus cosine squared 2x. If you're not familiar with how this product obtains this, I would encourage you to perform the appropriate distributions in the product so that way you can observe that this is in fact what you get. Once you have this, we have a few nice things that we can do. The first one being, right, observe these as individual integrals. So maybe you want to observe this as the integral of sine squared x dx plus the integral of 2 sine x cosine 2x dx plus the integral of cosine squared 2x dx. So now we have three integrals that fit very nicely into that category of these are trigonometric integrals, where we have products of trig functions. But in the case of the first and the last, we don't have that fits nice into either of the first two guidelines. So we have to go to the guideline that says to reduce the powers, right? Even powers aren't very nice, so we have a power reducing formula. That formula can be found on our sheet of formulas. So the power reducing formula for sine is 1 minus cosine 2u divided by 2. And the power reducing formula for cosine is 1 plus cosine of 2u divided by 2. So we need to double what we're putting into the function. So sine was 1 minus, copy that correctly. 1 minus, it's not 2 times that, it's just a single. 1 minus cosine of 2x divided by 2 dx. All right, I'm going to pause for just one moment here. All right, so we were able to reduce the power here, and we want to reduce the power here as well. But before I get to that one, let's work with this middle piece. We've seen an integral like this one before, and what we can recognize is that we have, let's see here, product to sum formulas. So I have sine of u times cosine of v. Now, what's a little bit interesting here is we want to recognize that what multiplication, order of multiplication doesn't matter. So I've written it as sine x times cosine of 2x, sine of x times cosine of 2x, which would tell us to do sine of x plus 2x is sine of 3x, and sine of x minus 2x is a negative x. And that's fine. And in fact, let's just go with that because here's the formula. Let's just follow it strictly. And if we do that, that's going to give us, first of all, or before we do that, notice it's a 1/2 here, 1/2. So this is going to be 2 times 1/2. So the 2 and the 1/2 will cancel. 2 times 1/2 cancels. But this gives us the, I'm going to double check it one more time, sine of the sum plus the sine of the difference. So that would be sine of the sum is 3x plus sine of the difference is sine of negative x. And then power reducing formula for this last one, cosine squared can be reduced as 1 plus cosine of twice the angle. So twice this angle would be 4x instead of just 2x, and then divide by 2. So this is my new collection of integrals that look, for the most part, much nicer. This one we could be careful with. So I'm just going to repeat this entire line here. Maybe actually pull out the 1/2. So I have 1 minus cosine of 2x dx plus cancel these out. This is sine of 3x. And this, sine is an odd function, so I can actually pull that negative right out. So this is minus sine of x dx. Pull out the 1/2, so I have plus 1/2 of the integral 1 plus cosine of 4x dx. And now each of these are a little bit easier to see that we can find these integrals. So this is 1/2 times integral of 1 is just x. Integral of negative cosine is negative 1. Right, the 2 we're going to end up having to cancel the 1/2. So integral of cosine is sine. Inside stays the same. And we need the 1/2 to cancel out. What do I mean by that? Well, if I take the derivative of sine of 2x, I get cosine of 2x, but the chain rule says to multiply by the derivative of 2x, which would be multiplied by 2. So I would have 2 cosine 2x, but I don't want that. I want just cosine 2x. So I introduce this factor of 1/2, so that way the 2 and the 1/2 reduce. All right, plus integral of sine of 3x is similarly 1/3 cosine of 3x. 1/3 times cosine of 3x. But I also want to recognize that the derivative of cosine is negative sine, so I'm going to need that negative there as well to make sure that this is positive. when I think of it as differentiating to find this. Integral of sine is cosine, so that's just cosine x. And here we have 1/2 of, all right, so this guy is going to give us integral of 1 is just x. Integral of cosine is, we already said that integral of cosine is sine. I'll keep the inside the same, but in order to handle this 4, right, differentiating would give us 4 cosine of x. So we take 1/4 of that to have those cancel when we differentiate to obtain the integrand, right? That's verifying our work, checking what's going on. Essentially chain rule, perform substitution if you need to. And plus c here at the end. So we can simplify this a little bit. This is 1/2 x plus 1/2 x, so that's just x. 1/2 times a negative 1/2 of sine of 2x gives us minus 1/4 of the sine of 2x minus 1/3 cosine x minus cosine of x plus, I put this over here already, 1/8, distribute to 1/2, that is, 1/8 of the sine of 4x. And don't forget the plus c. And really that looks absolutely fine. If you wanted to, you could group together your sine terms and your cosine terms, and that might help it look a little bit nicer, but it's not completely necessary. But that's what we're looking for, and that's it. We didn't perform any substitutions, so there's nothing to substitute back. So not terribly bad, just need to unfortunately multiply out and then use the power reducing formula for the first and last integral, and then use what we've seen before actually for evaluating this. But that's all. So that one isn't so bad, that's a little bit shorter. Thank you for your time and attention. If you have any questions, make sure that you let me know. Send me an email, stop by during my office hours, or schedule an appointment. In any case, I hope I can answer your questions, but you got to make sure you ask them. Have a great day.